range that you could shoot for. Not always achievable, but they're kind of a guideline. What affects this minimum value? There's a lot of factors that go into it, and these are listed here. Of course, you have to consider your seed particle size and the material that they're made of. How reflective are they? If you're in water flow, what is the index of refraction delta between the water and the seed particle? Your collection angle. Remember, we're using knee scattering most often, unless you're using fluorescent particles. If you can set your cameras up in a forward scatter direction, you can collect a lot more light. Light scattering is more efficient at that angle. Also, you have to consider what medium. Are you in a gas or a liquid flow? If it's liquid, how turbid is that liquid, which will affect attenuation, both the light that's going into the measurement volume and the scattered light that's coming off your seed particles. And the number of windows that you have. If you're going into a wind tunnel and you've got several windows that you're going through, you're going to have light that's reflected off those surfaces, which is eventually going to cut down on your laser energy density that makes it into your measurement volume. So you have to really think about your setup and how can you maximize the amount of light that makes it into your volume, and also that can make it out. As mentioned a couple times already, if you have a column-emitted laser volume, you can use mirrors to reflect the laser back on itself to increase your energy flux. And this is shown here, not very clearly, but there's a mirror on this left side which reflects this collimated volume back across the measurement volume. So you basically use your laser power more than once through the measurement volume.
Can you just send it back through on the same path, or do you need a different angle too?
Well, it depends. In this case, it was sent back through the same path. Other configurations for, say, lower speed flows is taking a small laser beam and having a slight angle, and you just ricochet it back and forth through a set of mirrors that you can use.
In this experiment, it was really dangerous because we had a 1-2 laser, and we really had to put another beam down for the reflected beam. We need to be very careful that the laser is not reflected directly in itself and we damage the laser.
That's what I meant.
So you must start off axis and
so you have to be
careful where the beam goes back. And you tilt just a little bit, I mean 1 degree, you know.
Okay.
Just not
that's what I was asking. Okay.
Yeah. Good point.